दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Children, we have discussed in our last class simple electropositive radical. Now we'll come to electropositive compound radical. Second category, electropositive compound radical. There are very few radicals are there. So now radical means an atom or a group of atoms. Compound radical means a group of atoms. There are group of atoms with a positive charge. So a group of atoms with a positive charge constitute electropositive compound radical. Electropositive compound radical. A group of atoms. A group of atoms of different elements acting as a single unit, acting as a single unit with positive charge, constitute a compound electropositive compound, constitute electropositive compound radical. So this is the definition of electropositive compound radical. So their name, it is very important, their name ends in IUM. Their name ends in IUM, and their name is ending with IUM, and a name will come from where? From the things present in there. So now, there will be group of atoms acting as single unit. So example I am giving you. So we have NH3. This NH3 is called ammonia. NH3 is called ammonia. It is a neutral molecule. When this ammonia reacts with H+, this form, then nitrogen, then 4 hydrogens, 4 NH4. So the whole of them, they will carry the positive charge. Nitrogen was no charge, ammonia was no charge. This is ammonia. It is carrying, it combines with H+. So total number of hydrogen how many? 4. But nitrogen valency is 3. It is increased one positive valency. Hence it is ammonia. So ammonia, its name comes as ammonium. From ammonia and IUM. So ammonium. You see how easily you are writing the formula. Ammonia, we know ammonia, NH3. So IUM means electropositive compound radical. Hence it is ammonium. Similarly, if you come to PS3, this is called phosphine. Now this phosphine, when combines with H+, so phosphorus, now 4 hydrogen atoms, PH4, and a positive charge, PH4 plus, it is called phosphine. So phosphonium. So last will be what? IUM. So phosphonium. Now we have H2O, water. This is called hydra, and hydra, whatever you call it, hydro is called as a hydro, and H+, and this becomes H3O plus. This becomes H3O plus. it is hydronium. You see, there is no reason for remembering. IUM means it is a compound, a positive charge compound radical. IUM, and from water, hydro is a H2O, so H plus is hydronium. Now NO2 is nitro. NO2 is called nitro, NO2 plus, this is called nitronium. This is called nitronium. So these are the few electropositive compound radicals which we will be dealing in our plus 2 course. So I am writing these 4 only. Subsequently, when we will be reading chemistry, we will come across much more number of compound radicals, and that we will be using them. Now only we will confine now to ammonium, phosphonium, hydronium, nitronium. Other radicals we will be coming across this. We'll learn them subsequently. Now we'll come to the third type of radicals. They are electronegative simple radical. Electronegative simple radicals. Electronegative simple radicals means they are simple means it will contain one atom. Radical means it will have a charge, and what is that? It will have a negative charge. Hence they are called as electronegative simple radicals. So these electronegative simple radicals, they are called as what? They are called as anion. These electronegative radicals, they are what? They are called as anion. And they are also called as acid radical. They are also called as acid radical. So we take the symbol A. We take the symbol A here, A, and negative charge minus, and we write here M. A minus M means M may be 1, 2, 3, 4, 5, and minus. So the charge, for me, for use of to write a formula of the compound, I will be using this. A for acid radical, negative charge, electronegative, and one atom minus. So we'll take as A charge. So who will form? The atoms of those elements. Atoms of those elements. Atoms of those elements have a strong tendency to gain electron to attain octet or nearest inert gas structure. I am writing here NIGS. will form electronegative simple radical. Electronegative simple radical. Atoms of those elements have a strong tendency to gain electron. To gain electron means to attain octet or nearest inert gas structure, NIGS, are called as the form electronegative simple radical. The charge on them is 8 minus group number. 8 minus group number. The charge will be 8 minus group number. Their name ends. Their name end in I, D, E. Their name and in ID. So this is one point, this is the second point, this is one point, this is second point, the third point. The atoms of the elements which have a strong tendency to attain octet by gaining electron will form simple electronegative simple radical. Who are they? The group 7. They have 7 electrons. They will form electronegative simple radical. Group 6, they have 6 electrons, so they can take 2 electrons, form it. If you come to group 5, they have 5 electrons, they can take 3 electrons and attain octet, so they will form. Group 4 elements, they can take 4 electrons and attain octet, hence they have 5. So this is the very simple. So now we come to conclusion. Who are the elements will form electronegative simple radical? All the elements of group 7. Who are? Fluorine, chlorine, bromine, iodine. They have fluorine, chlorine, bromine, iodine. They have 7 electrons in their outermost shell. So they will form electronegative simple radical. If you come to group 6, oxygen, sulfur, they will form. In group 5, nitrogen and phosphorus, they will form. And in carbon, and in group 4, the carbon will form. These are the radicals only they will form. And their name will end in IDE. The name will end in IDE. And the charge on them will be 8 minus group number. Charge minus. So group, all the elements of group 7, 7 electrons, 8 minus 7, they will charge minus 1. The elements of group 6, 8 minus 6 minus 2. The elements of 5, 8 minus 5 minus 3. So very simple way. Now you have decided their formula, you have decided the charge, and you can write everything now to yourself. There is nothing to remember what you are doing. Chloride minus 1, chloride minus 1, chloride minus 1, bromide like this you are remembering. You are asked in the school, whether it is ICSE or CBSE or Odisha board, always they tell you to remember. Please don't do that. Try to understand. You find your own way how we can do it. And we can, and this is our all-in-one. I told you last class, all-in-one. Everything is there in the periodic table. You just have a periodic table in front of your table and carry a periodic table in your notebook, and wherever you need, you open it and ask it. He will give you the knowledge. Now let's come to all the group 7. Group 7A. Group 7A modern periodic table and 17 long form periodic table. And these are, who are the elements? The elements are fluorine, chlorine, bromine, iodine. Astatine will not form, they will form. Then what will be charge on them? They have 7 electrons. Charge will be A minus 1. A for acid radical, and charge is minus 1. 8 minus 7 is minus 1. You have 1 as minus 1 this. So fluorine will form fluoride. Fluorine will form fluoride F minus 1. Chloride, chlorine will form chloride Cl minus 1. Bromine will form bromide Br minus 1. And iodine will form iodide I minus 1. Very simple. Chloride, fluoride minus 1. Chlorine, chloride minus 1. Bromine, bromide minus 1. Iodine, iodide minus 1. Now we'll come to group 6. Group 6A, the elements are oxygen, sulfur, selenium and tellurium, polonium. But these two elements will form negative radicals. Who will form? Oxygen and sulfur. They will not form negative radicals, electronegative radicals. Only oxygen and sulfur will form electronegative radicals. They have small atomic size and 6 electrons in their outermost shell. They have a strong tendency to accept electron. Hence their charge will them how much? 8 minus group number. Charge will be A minus 2. A stands for acid radical and minus 2 is the charge. So O will form oxide, O minus 2. and the sulfur will form sulfide S minus 2. Very simple. You need not remember sulfur, sulfide minus 2, sulfide minus 2, oxide minus 2. It's just oxygen group 6. So 8 minus 6 is 2, negative IDE. So their name is oxide IDE. Their name is ending in IDE. The name is ending in IDE indicates. Oxygen also forms another radical that is called peroxide. Peroxide. O2 minus 2. O2 minus 2. Oxygen forms another radical, peroxide, O2 minus. Per is a word higher. Always per is a word higher. Hypo is a word lower. Hypo is a hyperacidity. So when you are suffering from acidity, where you have less acidic, so per hypo. Hypo is a word we are using for lower. Per is a word we will be using in a higher in chemistry. We will be using the word per very much. So this. Now then we will come to group 5. We'll come to group 5. Group 5A, there we have the elements nitrogen, phosphorus, arsenic, antimony, bismuth. So only these two elements, they form simple electronegative radical. Who are they? Nitrogen and phosphorus. How many electrons they have? 5 electrons. So the charge will be what? A minus 3. A for acid radical, 3 is the charge A minus 3. Because they are group 5, so the charge will be 3 and negative radical minus 3. So nitrogen will form nitride and minus 3, and phosphorus will form phosphide P minus 3. So these are the some simple electronegative radicals. So children, I told you IDE is a word we are using. IDE is a word you are using for electronegative simple radical. But there are two exceptions. I am writing some exceptions here. Some exceptions. Their name and in IDE. Their name and in IDE, but have more than one atom. These are the two exceptions. More than one atom. They have more than one atom, and their name is ending in IDE. So they are the exceptions. Who are they? Now hydroxide. Hydrogen, oxide, oxygen. So hydrogen OH minus 1. Its formula is OH minus 1. So somebody may question how you got it, sir. Now oxide I know O minus 2. Hydrogen we know H plus 1. So if you they combine, so this becomes OH minus 1. O is oxide, H is plus hydrogen. So plus 2 plus 1 minus 2 minus 1, and it is hydrogen is there, hydroxide. So somebody may ask, sir, why not oxide hydro? No, always we pronounce positive. We always pronounce positive first, negative next. So hydrogen is positive, oxygen is negative. So we write OH minus 1, hydroxide. Then another is cyanide. Cyanide, Cn minus 1. Cn minus 1. So its formula is Cn minus 1. Cyanide, Cn minus 1, hydroxide, OH minus 1. These are the two radicals where the name is ending in IDE, but they are not simple radicals. They are compound radicals, but their name is ending in IDE. So these are the two exceptions. Let's not get confused. So any radical ends in name in IDE, they form this. Now we'll come to electronegative compound radicals. We'll come to the fourth category, that is electronegative compound radical. So what is there here? So here they will have more than one atom and they will have negative charge. They will have more than one atom and they will have negative charge, and so electronegative compound radicals. So what happens if you go to the periodic table from left to right, from left to right in the periodic table, the negative character increases. If you go from left to right, negative character increases. So higher the group number, higher is the negative character. Lower the group number, stronger is positive character. Group 1, all are highly electropositive elements. Group 2, highly electropositive elements. But group 7, highly electronegative elements. So all the group 7 elements, group 6 elements, the negative character. So all the elements why all I will not use, I will use a word, most of the elements you can use. You can use a word, better word, most of the elements. Most of the elements combine with oxygen to form electronegative compound radical. Electronegative compound radical are called as oxyanions. Anions means negative radical and containing oxygen. जोटा आमे संस्कृत रे, हिंदी रे, ओडिया रे जुग्म पद बोले पीतांबर, पीत अंबर पीतांबर. पीत माने हलदिया, अंबर माने वस्त्र. जी हलदिया वस्त्र पिंधंती ताकू कहा जाए पीतांबर. किए ना जगन्नाथ महाप्रभु बुधवार और गुरुवार दिन से हलदिया वस्त्र पिरंदी एणु ताकू से दिन पीतांबर रूप पूजा करा जाए. सेई जगन्नाथ महाप्रभु शनिवार दिन नील वस्त्र पिंधंती एणु तांकू सेई दिन नीलांबर बोलिकी कहा जाए. नीलांबर, नील अंबर नीलांबर. जगन्नाथ महाप्रभु सोमवार दिन और शुक्रवार दिन धड़ा वस्त्र पिंधंती, श्वेत वस्त्र पिंधंती एणु श्वेतांबर बोली कहती. एणु आमे ताकू जो सही लोक को नीलांबर ताकू कहगला पीतांबर, ताकू कहगला श्वेतांबर. कहीं ना श्वेत वस्त्र पिंधिचंती एणु ताकू श्वेतांबर बोली कहगला. जुग्म पद सेमती एठी oxyanion. It is an anion, means it contains negative charge, and an ion having negative charge is called an acid radical, and it contains oxygen. It contains oxyanions. Charge on them, what will it charge? On them generally is equal to 8 minus group number. I am using the word generally, means it may somewhere we may have different, somewhere we may have different. साधारणतः बोली आमे कहूछु most of the things, most of the cases रे semane group minus ता charge रो quant number थाबा तांकर 8 minus group number. एणु ताको आमे कहूछु generally 8 minus group number. Then what will be their name? आमे ताको generalize कर दोचे their name. All oxyanions, the name of oxyanions end in ITE and ATE. The name of oxyanions end in what? ITE and ATE. When ITE, the name will end in ITE, or the name will end ATE. Then when ATE, when the element uses its lower valence state uses its lower valency state, its name ends in ITE. When it will use lower valence state, its name and in ITE. When the element uses higher valence state and combine with oxygen with oxygen, its name and in ATE. So ATE केतବେଳେ ହେବ ଯେତେବେଳେ ସେ ହାୟର ଭାଲେନ୍ସ ଷ୍ଟେଟ୍ ୟୁଜ୍ କରିବ ATE ହେବ, ଯେତେବେଳେ ଲୋଅର ଭାଲେନ୍ସ ଷ୍ଟେଟ୍ ୟୁଜ୍ କରିବ ITE ହେବ ଲୋଅରରେ, ହାୟରରେ ATE ହେବ। The third ହେଲା when the element uses its higher valency state more than ATE state, its name begin with par, and end in ATE and in ATE माने पर आरंभ हबो आउ ATE रे सरीबो। जदि if it is using higher valence state higher than ATE, then per ATE, it will be per ATE. When the element uses its lower valence state lower than ITE, its name begin with hypo and end in IT. So all the names of these oxyanions amar hala ATE rahila jodi higher valence state use करचंती, lower hala ITE रहिबो, जदि ATE टू अधिका हेतिबो ताहले तार पर रे आरंभ हबो आउ ATE रे सरीबो, जदि आठु कम हेतिबो ताहले हाइपो रे आरंभ हबो and ITE रे सरीबो। एइभली names we have four type of names आसीजिबो हमर। जनरली समस्तंकर ATE ITE रहिबो, किंतु किछि जगह रे जोटी हायर यूज करा जाइथिबो, हायर टू हायर हेतिबो पर ATE, लोअर टू लोअर हेतिबो ताले हाइपो पदटा यूज करा जाए लोएस्ट एंड हाईएस्ट यूज कला को पर यूज करा जाए। हाइपो एसिड्स, पर एसिड्स, पर सॉल्ट्स, हाइपो सॉल्ट्स एमती बहुत जगह आसीबो। सो चिल्ड्रन यू गेट एक्वेंटेड विथ दिस वर्ड्स। पर पद यूज होउची मान तब सब बेले यूज हम भाबिबो जे हायर यूज हेची, हाइपो जदि पद यूज होउची ताले तुम भाबिबो इट्स लोअर यूज हेची। ताहले मु लेट मी स्टार्ट विथ ग्रुप 7 because the most electronegative element are, who are they? Group 7 elements. We will come to group 7 elements. Group 7A, who are the elements? Fluorine, chlorine, bromine, iodine. These are highly electronegative elements. They have 7 electrons. So what will be their charge? The charge will be how much? Charge will be -1. Kaiki 8 minus 7 is 1 and electronegative radical -1. Fluorine is more electronegative than oxygen, so does not form electronegative, does not form oxyanions, এটা গুলো তোমার এন্ট্রান্স কোশ্চেন হই পারে। It may be a question in entrance. The element does not form oxyanion. The electronegative element which does not form oxyanion is, it will there. So answer is fluorine, because the fluorine is the most electronegative element. Cesium is most electropositive element. So this. So then what? Who will form? All other. Chlorine will form, bromine will form, and iodine will form. So now we'll come to chlorine. Let's take the case of chlorine. Chlorine forms a radical called ClO4 minus. It combines with oxygen. Chlorine combines with oxygen to form a radical ClO4 minus. It will combine with oxygen to form ClO3 minus. It combines with oxygen to form ClO2 minus. It combines with oxygen to form ClO minus. Chlorine combines with oxygen to form 4 electronegative compound radicals: ClO4 minus, ClO3 minus, ClO2 minus, and ClO minus. তাহলে হায়ার ভ্যালেন্সি হায়ার হবে কি, হাইয়েস্ট হবে কি না এটা? কারণ 4 oxygen is there, it will be the highest valency state. যেহেতু নেগেটিভ এনায়ন এটিরে সরিব ଆଉ ହାଏଷ୍ଟ ଅଛି ଏଣୁ ପର ଆରମ୍ଭ ହେବ, ଏଣୁ ଆକୁ କୁହାଗଲା ପର କ୍ଲୋରେଟ୍ ତାକୁ କୁହାଗଲା। ତାଠୁ ଏଟା ଏଟିରେ ହେବ କ୍ଲୋରେଟ୍ ଏଇଟା ହେବ। ତାଠୁ କମ୍ ଅଛି କ୍ଲୋରାଇଟ୍, এটা ସବୁଠୁ କମ୍ ଅଛି hypochlorite. Somebody may put me a question, sir, how do you know this? Now you see oxygen is always what? -2. So let me find in perchlorate. Chlorine is X. So X minus 8 is equal to -1. So X is how much? +7. I will come to chlorate, ClO3 -1. I take chlorine X. So X minus 6 is equal to -1. So X is +5. ClO2 minus chlorine is X minus 4 is equal to -1. X is +3. Then ClO minus, so here ClO minus, you have X minus 2 is equal to -1, therefore X is +1. So in perchlorate, chlorine is in +7 state, in chlorate it is +5 state, in chlorite +3 state, and hypochlorite +1 state. So when an element uses a higher state, it is AT. When it is highest state, it is for AT. When it uses lower state, IT. When it is lower to lower state, hypo IT. So perchlorate ClO4 minus, chlorate ClO3 minus, chlorite ClO minus, ClO2 minus, and ClO minus. Now bromine and iodine, they are present in group 7. So I told you the elements belonging to a group exhibit similar character. The elements belonging to a group exhibit similar character. So bromine, iodine are there in group 7. So they will be exactly like chlorine. They will be exactly like chlorine. So bromine will form what? BrO4 minus. Its name will be perbromate. Perbromate. And it will form with oxygen BrO3 minus. It is a bromate. It is bromate. And it will react bromine with oxygen BrO2 minus. It is bromite, like a chloride, bromite. And it BrO minus. It is hypobromite. Hypobromite. You see how easy it becomes. Because they belong to same group, they exhibit similar character. I told you the elements belong to a group exhibit similar physical and chemical properties. So chlorine and the way the chlorine will exhibit, the bromine will also exhibit. Similar, iodine will be IO4 minus. IO4 minus, it will be periodate, and IO3 minus, iodate, and IO2 minus, iodite, and IO minus, hypoiodite. Hypoiodite. How easily we are, so no one, no all. There is saying, jemti भात आमे भात हांडी रे गोटे चिंपिले आम पूरा भात हांडी को आमे जानि दउचे सेमते जदि आमे पढिबा सिस्टमैटिकली आमे जिबा ताहाले आमे सब जिंस को मन रखिया दरकार नै आमे चाहिलु ऑल ऑक्सीजन आयंस हु आर द ऑक्सीजन आयंस व्हेन इलेक्ट्रोनेगेटिव एलिमेंट combine with oxygen, when an element combine with oxygen, it forms an electronegative radical called oxyanions, and charge on them will be 8 minus group number. So chlorine so higher valency state ATE, lower valency state ITE, higher to higher per ATE, lower to lower hypo ITE. So ClO4 minus perchlorate, ClO3 minus chlorate, ClO2 minus chloride, ClO minus hypochlorite, BrO4 minus perbromate, BrO3 minus bromate, BrO2 minus bromite, BrO minus hyporomite. Now coming to IO4 minus periodate, IO3 minus iodate, and IO2 minus iodite, and hypoiodite. You see, there is nothing to remember here. Just you know that the group 7 has the elements fluorine, chlorine, bromine, iodine. Fluorine is more negative than oxygen, will not form electronegative radical. So all they form, they is hence the same group, so they exhibit this. Now we will come to group 6. I am going to group 6. Group 6A. So if you come to group 6A, these have oxygen, sulfur, selenium, tellurium. These are the elements. So they will go to sulfur, will react with oxygen to form radicals. So sulfur react with oxygen, so charge will be -2. Their charge will be how much? -2. 8 minus group number, 8 minus 6 is 2, and negative radical -2. So sulfur forms SO4 -2, and it forms SO3 -2. Since group 6 -2, sulfur SO4 -2, so it is higher, it is lower. See, 4 oxygen higher, 3 oxygen lower. So this will be ATE, this will be ITE. So sulfate, it is called sulfate, hence its name is sulfate, and its name is sulfite. Its name is sulfite. Now when it forms other radicals, sulfur, oxygen also combine. when an oxyanion combines with H plus, the name of the radical, the name of the anion will begin with bi. will begin with bi. So we have sulfate, SO4 minus, oxyanion. Combine with H plus. Combine with H plus. What will it will form? HSO4 minus. Why? Here is minus 2, here is plus 1. This. So its name begins with bi. Its name begins with bi. So its name will be bisulfate. Its name will be bisulfate. And SO3 minus 2 will combine with H plus, will form HSO3 minus. It is bisulfite. Children, you see how systematically I am teaching you, and I am not asking you to remember anything. I am just, this bi word I will be using everywhere. Everywhere there is an oxyanion and they will form. And now sulfur forms another radical that is called S2O3 minus 2. S2O3 minus 2. This is called thiosulfate. This is called thiosulfate. It also forms another radical S4O6 minus 2. It is called tetrathionate. Tetrathionate. So tetra means 4, thio means sulfur, and oxyanion. So tetrathionate. And here is thio. Thio means sulfur. So thio. So thiosulfate. These two, they are, I will be teaching you. When I will teach acid, I can explain you very better way this. So these are the radicals. They are there for group 6. Now we'll come to group 5 and group 4. We will complete these two, group 5 and group 4, so that we will complete our this compound radicals. So now we'll come to group 5. Group 5. Who are they? Nitrogen, phosphorus, arsenic, antimony, bismuth. So mostly nitrogen and phosphorus, they are electronegative elements, and they combine with oxygen to form oxyanion. So their charge will be generally minus 3. But so nitrogen is a exception here. Nitrogen combined with oxygen to form two radicals, NO3 minus and NO2 minus. Nitrogen combined with oxygen to form NO3 minus and NO2 minus. So who is higher? NO3 is higher. Who is lower? NO2 is lower. So it is called a nitrate, and it is called nitrite. If you come to phosphorus, PO4 minus 3 and PO3 minus 3. Group charge is minus 3. Group charge is minus 3. So phosphorus, so higher, this lower. So this is called phosphate. This is called phosphate, and this is called phosphite. This is called phosphite. Lower valence state ITE, higher valence state ATE. Now we'll come to arsenic. Arsenic forms ASO4 minus 3. So this comes arsenate. Arsenate, and ASO3 minus 3, it is called arsenite. Arsenite. So very easy. You see, there is nothing to remember. Many often we have a very strong idea. We have to remember. You have to remember. Now we have systematically we came from the concept. At the last, I am discussing you with carbon. So group 4A, that I will complete this group 4A. Who are the elements? Carbon, silicon, germanium, tin, and lead. All of them will form, all these elements combine with oxygen to form oxyanions. All these elements combine with oxygen to form oxyanions. They combine. Now I am teaching you for carbon and silicon only. Rest other things we will read later on. So carbon will form CO3 minus 2. So this is called carbonate. Carbonate. And silicon forms SiO3 minus 2. SiO3 minus 2. It is called silicate. It is called silicate. Now, then what happens when a T radical or IT radical combines with H plus, its name begins with what? Bi. So now carbonate is there, CO3 minus 2, it is combining with H plus, so this will form HCO3 minus. So its name will be bicarbonate. It is bicarbonate. So this silicate silica जोटा बाली आमे कहूचे sand is silica and silicate SiO3 minus 2. A sand नहीं we prepare the glass, sodium silicate is the compound from we use the glass. So these are the C oxyanions, all the elements of carbon, group 4, group 5, group 6, group 7, they form oxygen and they form electronegative compound radical. They are called oxyanions, and when they use higher valency state, the name in NAT. When they use lower valency state, the name end in ITE. When they use higher to higher valency state, then it's para-ITE, and when they use to lower, they are called hypo-ITE. And when the oxyanion combine with H plus, its name begins with biphosphate, bicarbonate, bisulfate, bisulfite, like this. So dear students, so these are the some oxyanions I gave you as a radical. Simple electropositive simple radical, electropositive compound radical, electronegative simple radical, electronegative compound radical. Next class we will think about another radical that is called a complex compound radical. So you get acquainted with these names. Try to write the formula 4 or 5 times. Write the name. Don't get tired. Write the name. So next class I will use these radicals and write the formula for acids and bases. I will not force you to remember the formula of acids and bases. So always one thing, success in life is never an outcome of circumstances or opportunities, but it is always of hard work and perseverance. So circumstances everybody will not get. Opportunities everybody will not get. We are not having classroom teaching, though the classroom teaching should be there, and our circumstances are not helpful to us, but at this critical juncture we have using our time and using this, our hard work, our perseverance will be now helping us studying this up everywhere in lifetime. Remember this, success in life is never an outcome of the opportunities or the circumstances, but it is of hard work and perseverance. So this is the sentence I want to tell you at the end of my class. Go through them. Next class I'll come and I'll teach you complex compound radical and write the formula for acids and bases by using this acid radical and basic radical in a very scientific manner, so that you will not remember anything but you will digest everything and you will be expert in chemistry. Thank you very much for your patience, listening and understanding.